Alrighty, geometry students, welcome to homework 3.5 on slope. We continue with chapter 3 on lines, but now we're moving away from transversals and talking more about graphing on the coordinate plane. Now, as I begin, I'll just give you a heads up. A lot of this has already been written down because I was in the middle of my last video and things froze. So I'll be describing the first 2/3 of this assignment and then get adding some of the writing, which shouldn't be a problem. But let's dive right into talking about slope, which is something you should have covered in Algebra 1. And so hopefully this is a helpful review. Though if you struggled with it, here's a great chance to strengthen your understanding because it's very, very important in this year in math and also moving forward next year. Okay, so definitions. So first we have rise versus run. And as you can see there, the rise describes a change in y values. And so I had that line graphed over there. And the rise of that line is how much the y values have changed moving vertically. So you can see that the line goes up 7 spots upwards. So it has a rise of 7. You can see that even if I look at the coordinates of -1, -2, and the other higher point is at 3, 5. Look at the second number of those coordinates, -2 to 5. That the difference between those two numbers is in fact 7. 5 minus -2 is 7. It's written there in the blue. And so even whether it's numerically or on the graph, I can see that there's a rise on that line, a change in its y values of 7. Then we have the run, and that's a horizontal change that is, as you can see in the green there, the points are 4 apart horizontally, and so that's called a run of 4. And that's confirmed by the fact that you have -1 to 3, and that the difference between those two digits is in fact 4 as well. So we have a rise of 7 and a run of 4. And again, in those coordinates, the first in the parentheses, the first number is your x, the second is your y. So it was a little tricky just because we say rise and run. Don't think that that's actually the opposite order of coordinates. The first number is the run, the x. The rise is the second number, the y value or the rise. Okay, so rise is vertical, run is horizontal. And when we put those two together in a rise over run, we get something called slope. And so we have our second definition here, which is slope, and a ratio of rise over run. And as you see written in red there, that's basically the steepness of a line. Depending on how much something rises versus runs, that tells you how steep the line is going to be. A very steep line has a lot of rise and a little bit of run, and a more shallow line has a little bit of rise and a whole lot of run. Okay, and so the slope of the first line up here, that would be 7 over 4. The second one that I've drawn down here, you can count out the rise over the run. And again, sorry, it's a little messy because I did it previously, but it rises 4 and then runs 2. So every 4 points it rises, it runs 2. And so that would be a slope of 4 over 2, putting the rise over the run. However, you can treat ratios just like a fraction. And so 4 over 2 actually reduces to 2 over 1. And so that line is, you could think of it both ways. It either goes up 4 and then runs 2, or it goes up 2 over 1, up 2 over 1. They're both basically the same. And this I can write is just like equivalent fractions. 2 over 1 is the same slope. If I double those, that's the same slope as 4 over 2. And if I were to double that again, it'd be the same slope as 8 over 4. On and on and on. And if you had a line there, you could count the slope either way. You could go up 2 over 1, or you could go up 4 over 2, or you could go up 8 and over 4. It would all be the exact same slope. Okay, so let's get to the questions. Again, slope is rise over run. And actually, you know what? Let me write one more thing here. The way in which you find slope, next I'm going to erase these equivalent. Well, we'll keep it. Why not? Just change colors. The way that you find slope is what we just did in these two problems, is you find the change in rise. So you have y, you have y minus y over x minus x. And what that means is you're finding that's the same as saying the change in rise over change in run. And that little triangle is just the symbol delta. That means change. So rather than write out change, we use little triangles. And so if we're going to do this in one of the later questions, but if I want to find the slope
and I don't want to, I'm not going to draw it and graph it out like I just did here, you would simply find the slope by subtracting the two y's and then subtracting the two x's, similar to what I have up here. You can get that slope of 7 over 4 by right here, subtracting 5 and negative 2, which are the y values, and then subtracting the two x values, which are here, and then you get that rise over run. Okay, and we'll be doing that in one of the questions because you want to be able to take 2 points and find the slope between them. But the first question just deals generally with the appearance of slope. And this is really a helpful trend to take notice of, is that whenever you have a positive slope, you have to sketch each one out. But a positive slope, when we read, climbs left to right. So we read left to right. So think when we say climbing, we mean it's increasing as we move more and more to the right, more and more towards infinity on the graphs. Okay. That's the first one. Negative goes the opposite, is that from left to right, it's declining. It's going down as you extend to the right. And so you want to be able to look at a graph, a line, and go, I can tell that's positive or no, that's negative, all based on whether it's climbing across your vision or it's declining across your vision. A slope of 0 is flat line. Nice, even path. You're riding your bike and it's easy, but it's not too easy. So it's not uphill or not downhill. It's straight across. And then when we say a slope is undefined, that is a vertical line. Straight up and down like a cliff. And we'll get into class why that is mathematically, 0 slope versus undefined. But the way I just kind of remind myself is you can walk on a slope of 0 and it's quite pleasant, nice and flat ground. But you cannot walk on an undefined slope. It's more like a cliff and you'd be falling to your doom. So vertical is undefined. You can't walk on it. Flat is, yes, you could walk on it. So that's a 0 slope. But again, you want to be able to quickly tell the difference of those. Makes life very, very easy. So question number 2, this is where the last one I had been drawing on. This asks, what's the relationship between the slope of parallel lines? And so I had 2 sets of parallel lines here, and what you can see is they all have the same rise over run. The first set have both a rise over run of 4 over 5, so that's a slope of 4/5. The second one have the same slope of down 4 or negative 4 over 2, and so that's a slope of negative 4 over 2, which again, as you can see, reduces to negative 2 over 1. The key idea there is that the slopes are the same, whether positive like the first set or negative like the second set. So that makes sense. If 2 lines are going to be railroad tracks or parallel to each other, they'd have to be perfectly rising and running together, or else one would tilt and eventually intersect with the other. So parallel lines have equal slope. Second question asks the same thing. Well, what about perpendicular lines? So I've tried to draw lines here that we would imply are perfect 90-degree angles, definition of perpendicular lines. And so how do their slopes compare? Well, the first set, we're going to ignore the first one here because you can, if you remember, just as a review, the slope of this line here would be 0. However, the slope of the vertical line would be undefined. And so that doesn't really work out for explaining our purposes. So we're going to ignore that one. I shouldn't have sketched that. But let's look at the slope of the second one. We can see that if I take this one, the positive line, it is climbing up 1, 2, 1, 2, and then running 1, 2. So it has a slope of 2 over 2, and that's going to reduce to a slope of 1 over 1. Okay. If we look at the negative slope, let's see what it does. It's going down 1, 2, and then over 1, 2. So it's got a slope of negative 2 over 2. And so then that means it has a slope of negative 1. And so right away, there's a key feature. If you have perpendicular lines, one is going to be positive and one is going to be negative. What these 2 lines don't illustrate is something that I will actually erase this one here and try to demonstrate. And that is, not only do perpendiculars, you're going to have one positive and one negative line, but it's even more similar than that. Bear with me. If we have let's do something a little flatter. And actually, I'll just explain it this way. If I draw a line, and let's find its slope real quick. First of all, you can see, is it positive or negative? That's a negative line. It's decreasing left to right. But let's find its slope. Its slope is 1, 2. I'll go there. Whoops. 1, 2, 3. So it's going to go down 3, and then it runs 1, 2, 3, 4, 5, 6. Notice also you don't have to go to the ends, the quote unquote arrows of the lines. If you find any 2 points that go clearly through an intersection, just use those 2 points. So this one goes down 1, 2, 1, 2, 3, and then it runs 1, 2, 3, 4, 5. So it runs 6. So this guy has a slope of -3 over 6, and that reduces to -1 over 2. So it goes down 1 over 2, down 1 over 2, down 1 over 2. So let's say, what would its perpendicular line be? Well, first of all, you know if this one's negative, to go perpendicular, the other line would have to go positive. But the mistake a lot of students make is they think, okay, so I'm just going to say it's positive 1/2. Well, if I were to take a line that crosses through it and I were to go positive 1/2, let's change colors, and go, okay, so that means the other line would go up 1 over 2, up 1 over 2. That would make a line that looks like this. And as you can see, that's not perpendicular. It looks more like a flat X. And so positive 1/2 is not the perpendicular slope. Let's erase that one. What it actually is the negative reciprocal. So in other words, the positive slope isn't 1 over 2. It is 2 over 1. Okay? It's the original slope here, but with the opposite negative sign and the fraction or the ratio flipped over. That's what that word for that is reciprocal. So if I start at that same point and now I go up 2 over 1, up 2 over 1, and I sketch that line, boom, look at that beauty. That gives me this beautiful right angle. And I can see that is a perpendicular line because I changed the negative sign and I flipped the fraction. So the way we write this, perpendicular lines, we can write it out, is we can say that perpendicular lines are negative reciprocals. So you change the sign and you flip it. And the way that another way to write that is if you have a slope m, then the perpendicular slope is 1 over m negative. Okay? So you take whatever it was and then you flip it and you make it change the sign. And that'll give you 2 lines. Whatever this one is, the other one will be at a perfect 90 degrees to it in that case. Whereas parallel are exactly the same. Okay, so here's a little practice. If I have a slope of -2, what is the slope of my parallel line? Well, my slope of my parallel line is m equals -2. Okay, because if I were to take one line and go down 2 over 1, down 2 over 1, there's the first line, and I want a line that's parallel to that. If I go here, if I go down 2 over 1, down 2 over 1, and I graph that, boom, perfectly parallel lines. Okay, perpendicular, my slope is going to be, of the perpendicular line is going to be the opposite. So it's going to be positive because the first one's negative, and it's going to flip 2 upside down. So instead of 2 over 1, it's going to be 1 over 2. And that's the exact same one I just used in an example. But again, we can see that illustrated. If I have one line starting here that goes down 2 over 1, down 2 over 1, there's my slope of -2. And I pick one of those same points, and now instead of going down 2 over 1, I go up 1 over 2, up 1 over 2, up 1 over 2, and I graph that. Bada bing, bada boom. What a beauty. I get nice perpendicular lines, okay? So you should be able to do that with any example. If they give you a slope, you should be able to say, oh, the parallel slope is exactly the same. The perpendicular slope is the opposite sign flipped over. Okay, and lastly, we come to number 5. And sorry, I actually clicked away from it. I need to see what number 5 is. Please bear with me. Apologize. Speed ahead, skip ahead in the video. Just a second if you want to. Okay, question number 5. Oh, how do you find slope
of a line using 2 points, make up an example. So for this one, we're going to practice finding the slope from 2 lines. And rather than give you my own set, I wanted to show you that you can pretty much create any set you want and you can do it yourself. So let's just pick my favorite 2 points in the whole world, 2, 3. And let's pick another set of 2 points that are my second favorite in the world. And let's say they are -3. We'll go ahead and go all the -3, 5. We'll do those two. Okay, so now without even graphing it, I can find the slope between those 2 lines. I can remember that m equals the difference in the y's over the difference over the x's, the difference in the rise over the difference in the run. Now, the key thing here in terms of subtraction is it doesn't matter which one I subtract from the other, so long as I do it in the same order. So I'm going to start with the y's, and I'm just going to go left to right. So I'm going to say 3 minus 5, because those are my 2 y's. Here they are. 3 minus 5 over, I'm going to change colors for the x's. And now, since I did the first coordinate minus the second coordinate, I got to make sure I keep that consistent. So now I need to go 2 minus -3. 2 minus -3. And so, work through that. 3 minus 5 is -2 over 2 minus -3 is actually adding 3, so that's going to be 5. So I can see that the slope of this line is down to over 5, or -2/5. It doesn't reduce, and so boom, there is my slope. Okay, and just before we end it, I can go ahead and confirm this visually by quickly graphing it. You do not have to graph it, but I just want you to know that show you how you can be perfectly confident that you're right, is if I plot these 2 points and I go over 2, up 3, and then I go back 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. So there's my 2 points. And so that forms a line like this. So first of all, is it negative? Yes. Just by looking at the graph, I know that my answer should be negative. So that'd be a quick check on, did you get the sign right? Did you get a negative slope or a positive slope? Then I can see, does it really go down 2 over 5? Well, 1, 2, yes. 1, 2, 3, 4, 5. Yes, it does. So I can confirm it's got a -2 over 5. So if I'm looking for confidence, again, some people don't want the extra time, but if you're looking for confidence that your answer is right, there's a way to do that graphically. But the bottom line is you subtract the y's over subtract the x's. Alrighty, see you for next chapter and see you in class, and we'll discuss this then. All right, see you soon.